So let's do another example like that, but I want to point out that you should, after you write down the example, pause the video and try to work through this on your own before watching the video. So we have 7x plus 13 over 3x minus x plus 1 over 3x. So again, you should pause the video now and try to work through this problem. So we have a common denominator, but we have subtraction. So right away I'm going to change that to addition and change all the signs in this numerator. Now I'm ready to add these expressions. So we have 7x plus 13 minus x minus 1 over 3x. Combining like terms, 7x minus x gives us 6x. 13 minus 1 gives us 12 over 3x. And the numerator has a common factor of 6, so let's factor it out, and we're left with x plus 2 over 3x. And now we're going to cancel common factors. 3 goes into 3 once, 3 goes into 6 twice. And that's really all we can do, so we're left with 2 times x plus 2 over x. And this I would leave in factored form. If it were no longer a rational expression, if there were no fraction anymore, then I would multiply those out if the denominator were 1. But this I would leave. In this example, we have 2x minus 3 over x minus 1 minus x plus 1 over x minus 1. Again, you should pause the video now and then come back when you've completed this problem and compare. So we have subtraction. We're going to change it to addition and change all the signs in the following numerator. And now we're ready to add our numerators and keep the common denominator. Combining like terms, we have 2x and negative x, so that gives us x. We have negative 3 and negative 1, that gives us negative 4 over x minus 1. We look to see if we can simplify, but neither the numerator nor the denominator can be factored, and there are no common factors. In this example, we have 2z squared plus 7z over z squared minus 1 minus z squared minus 6 over z squared minus 1. You should write this problem down, then pause the video, complete the problem, and then come back and check. So we have subtraction. Right away we're going to change that to addition and change all the signs in the following numerator. And now we're ready to add our numerators. We have 2z squared plus 7z minus z squared plus 6 over z squared minus 1. Combining like terms, we have 2z squared and we have minus z squared, so that gives us 1z squared. Then we have 7z, and there's no other terms with just a z. And then we have plus 6, all over z squared minus 1. So now that we've subtracted these two expressions, we are ready to try to simplify. The numerator has 3 terms, so we're going to set up our double parentheses. Leading coefficient is 1, so we know this. Last term is positive, so both signs have to match the middle term. And we want factors of 6 that add up to 7. Well, 6 times 1 is 6, and they add up to 7. Doesn't matter which goes where. Denominator, 2 terms, GCF or difference of squares. Difference of squares. Z is squared, opposite signs, and then 1 is squared. And now we're ready to cancel any common factors, and we see z plus 1 here and here. And we are left with z plus 6 over z minus 1. Your textbook just loves these, and I'm going to show you the way they tell you to do it, and then I'm going to show you the way I'm going to tell you to do it. So we have almost the same denominator, but not quite. The x is positive here, the x is negative here. The 5 is negative here, the 5 is positive here. Your textbook will tell you to take this and factor a negative out of one of the denominators. So I'm going to choose this one. So if I factor out the negative, everybody changes signs. So we have positive x and negative 5. Now they're very close. And then, and actually I don't recall if they tell you, I think they tell you to put it out front and make it subtraction. So we have x minus 5 minus 3 over x minus 5. I personally wouldn't have even touched this in this section, but your book really throws it in all over the place, so you need to know it here. I would have dealt with this 2 sections from now, as opposed to that. Okay, this is what I would do. Okay, so I'm going to keep the first expression. And what I'm going to do is, remember on any fraction we can change 2 signs. So for example, if we have negative 2/3, I can change any 2 signs. I can make this, oh actually let's make it plus 2 over negative 3. That's better yet. I can change any 2 signs. So if I want to, I can make the numerator negative and the denominator positive. And that's what we're going to do. So if I change the signs of the denominator, and in essence what I'm doing is I'm multiplying the numerator and denominator by -1. So I'm really just multiplying by 1. The result will have the same value. And I get -3 in the numerator, and all the terms in the denominator change signs, so we get positive x, -5. And that's the way that I would deal with it. And now you have an addition problem. And so we have x minus 3 over x minus 5. And we're done. Let's do one more of these. So let's see if we can follow that same procedure. I have almost the same denominator, but not quite. So I'm going to keep the first one. And I really didn't want to change colors yet, and I did. But in the second one, I'm going to change the sign of every term in the denominator. So I get positive x and -2. And then I'm going to change the sign of every term in the numerator. So now we have 2x minus -4 over x minus 2, which is 2x plus 4 over x minus 2. And that numerator is factorable. There's a common factor of 2, which leaves x plus 2. And there are no common factors, so I cannot cancel anything, so I'm done. Or we could have done this, change to addition and change that sign. You have to do that when there's more than one term in the numerator, but when there's not, you don't have to go that route. So that concludes section 7.3.